In this video, we're going to show how to use R as a calculator, define objects in R, call functions in R, access and explore R data sets, and we're going to learn how to apply R base functions. Now, some of these you already saw previously, but we're going to go more in depth. So here I have RStudio pulled up. And if you'll remember last time, I talked about when we close RStudio, we typically don't want to save our workspace. Now to start out with, I want to talk about what you can do if you did save your workspace and then you realized, hey, I don't really want to have all those old things in my environment that I had before. And so you'll notice I've got RStudio pulled up, and if we look over here in my environment window, remember I can always pull and make these bigger, we'll see that I've got some variables left in here or objects left in here from the last video, and I'm not going to need them for this video, and usually I like to start with a clean slate. If this happens to you, one thing that you can do is you'll notice up here it looks like there is a little broom. What you can always do is click on this broom and it will clear everything out that is in your history. So before I do that, I do want to show you. Notice here we have the object A defined as 5, and I've got my console here. I haven't opened up a script yet. And so notice in console if I type in A, it's going to return 5 because we have 5 here. Now, I'm going to go ahead and clear this out. I'm going to tell it yes. So we cleared out the environment. And now notice if I type in A, it's going to tell me it cannot find A. So do keep that in mind. Once we clear our environment, all of those will be gone. And if we want to put them back in, we will have to redefine them. But this is the easy way, again, to clear that environment. All right, so what we're going to start out here is we're going to open up the script that goes along with this video. So that script is located on Canvas, so you'll want to make sure that you have downloaded the script for this lecture and stored it somewhere on your computer. So if you'll remember last time, we said if we want to open up a file, one way we can do that is click on File, Open File, and then we can navigate through our computer to find the file that we want to open. Now I want to show you a second thing that you could do. So notice down here we actually have a file explorer built into RStudio. And over here on the right there are 3 tiny horizontal dots. If you click on this, this will also open up the file explorer on your computer. And you can go through this way and also navigate through your folders until you find the folder it is that you are looking for. Now, the difference is when you use this file explorer, you'll notice that when I click on the folder, it looks like my folder is empty. This file explorer will only show the folders, not the individual files. So just because this looks empty doesn't mean that there's no files in this folder. And notice if I click open, now all the files in that folder will appear here. And then if I want to open them, so for example, I need to open up the Lecture 1 script that's going to go along with this video. So I can always click here and it will go ahead and open up that file. So either you can use this option up here or navigate here, but either way you do want to go ahead and open up this script, and again you'll download that from Canvas first. Alright, so as always, I like to start my scripts, remember, with those comments that just kind of remind me, what is the script actually being used for? And we start those with the hashtag, because anything that starts with a hashtag is going to be a comment. Those are just for the user. They're not actually going to be ran as code. And you'll notice for some of these lines I have multiple hashtags. The multiples don't really matter. That's just more a visual thing to help me break up lines. So I have CPH 565, Introduction to R Programming, Module 1 Lecture, the Basics. I'm going to go ahead and put my name in here. And then as always, I want to put in the last date that this file was worked on, and today is the 18th. And then we're going to move into using R as a calculator. And you'll notice here again, what I've got is a comment that lets me know what the next section of code is going to be doing. That. And you're going to see this a lot in these files. And again, as you're writing your own code, highly recommend using comments to help you organize your code. So the first thing we're going to look at is just some examples of some operations. So for each of these, we're not going to be assigning anything to be an object, so you won't see anything appear in the environment. everything we run is just going to populate into the console. So some basic operations that we can perform. We could perform addition using the addition symbol. So notice here we have 2 plus 2. Two different ways we could run this. We could either have our cursor and we could click run, or we could highlight the line and click run. But in either way, R tells us that 2 plus 2 is equal to 4. We could do multiplication. Multiplication is done with an asterisk in R. So 2 times 2 is 4. We could do division with a slash, subtraction, and then the caret symbol will take 2 to the power of 2. Now, a couple examples of incomplete lines of code. If we come down here in the console, notice that after each line of code was ran, we got the answer underneath. The line of code using the color scheme that I have, remember we saw last time you can change these color schemes. The code is in blue, and then the output is in white. Also, notice that once code populates into the console, we have this character right here in front of each of the lines of code. That character does not appear in the script. And in fact, if you put that character in the script, you're going to get an error when you try to run the line of code. So what that character is that character appears down here in the console, and it essentially is saying, hey, I'm ready for a new line of code. So let's see what happens when we run an incomplete line of code. So here we have 2 plus, but we don't say 2 plus what. So notice after we run the 2 plus, we don't get any output, and then also we don't see this character. Instead, we see a plus sign in its place. What this means is we have ran an incomplete line of code, and R is waiting for us to finish that line of code. So for example, I could type in the number 4 and hit enter, and notice this will give me 2 plus 4. Whenever you go to run new lines of code, always make sure that you can see this character in the console. Otherwise, you may have ran an incomplete line of code, and that can cause several errors. Right? You'll notice here I have the word unrecognized spelled incorrectly, and it's got a squiggly. Now this isn't a comment, so this is a purely visual thing, but in recent years RStudio has added in a spell check, which is really nice for comments. The spell check doesn't work for code, it just works for the comments. And so I can move my cursor in here and ask it to spell check for me. And we want to change that to unrecognized. So it is kind of a nice feature that's been added recently in RStudio. Now, suppose we have an unrecognized command. Suppose I wanted to take 2 times 2, but instead of using the asterisk, I use a lowercase x. Could run this, and notice it's going to give me an error. It says this is an unrecognized command. And so we do want to be careful that we are using, the correct syntax, otherwise we are going to get an error. So all of these are just using R as a calculator. We haven't assigned any objects. So now let's move into looking how we can assign objects to the global environment, and then we can use those objects to do things. So let's define a virtual 8-sided die. So here we have die 1, and I'm going to set that equal to the sequence 1 through 8. And we saw sequences in the last video. So notice die 1 takes the values 1 through 8. And then, just as a reminder, here's some other ways that we could define a sequence. So these are all going to be 8-sided dies, except I'm going to call them die 2, 3, and 4. So we could use the C function. We could use the SEQ function. And there's 2 different ways that we could use that SEQ function. One says that we want to go from the number 1 to 8 by steps of 1. The other one says we want to go from 1 to 8 where the total number of numbers in the output is equal to 8. In this example, either of these will give us the numbers 1 through 8. Now, once we've created the objects, we can see that they do appear here in the environment, and we can also call those objects by just typing their name. Now, when we run individual lines of code, we've seen that we can either just place the cursor or we can highlight them to run it. One of the nice things about highlighting is that we can actually highlight more than one line at a time. Now we do want to always be careful doing this. The reason for that is if you try to run a whole bunch of lines of code at once and you get an error, it can be somewhat hard to troubleshoot. So typically when I'm writing more complicated lines of code, or I'm doing something more than just calling the object names, I typically do run my code one line at a time. So that way if I get an error, I know exactly where that error is. You never want to be typing several lines of code and then try running it all at once. This is especially true of your homework. So as we progress in the course for your homework, you're going to write lots and lots of lines of code, and you never want to try to type out your whole homework and then run it to see if you get errors. You do really want to tackle that one line of code or one example at a time. Now that these objects are defined, we can perform operations on them. So let's see what some of these operations would look like. So remember that die 1 is an 8-sided die. It takes the numbers 1 through 8. And so let's see what happens if we add the number 2 to die 1. Notice if we add the number 2 to die 1, what we're going to get is for each element in die 1, we've added the number 2 to it. So we have 1 plus 2, 2 plus 2, 3 plus 2, and so on. We can also add objects to each other, or we can define them to be a new object. So for example, I'm going to create a new die called die 5 and set that equal to die 1 plus 2. And now notice that die 5 is stored. We can also use multiplication, division, subtraction, and we can take things to a power. And for each of these, as you see them appear in the console, notice for each of them, what it is doing is it's taking those individual elements of die 1 and performing that operation. And then, like I said a minute ago, we can also do operations between two objects. So we could take die 1 plus die 2. And again, this is going to do this on an element by element basis. So it's going to add the first element for die 1 to the first element of die 2, plus the second element of die 1, plus the second element of die 2, and so on. Now we do need to be careful here. The reason that we can add die 1 to die 2 is that they each contain 8 elements. If we try to add vectors that don't contain the same elements, then we're going to potentially get an error. And so it'll depend on whether or not one length is divisible by the other. And so I'll show you what I mean here. So in this first example, we're going to take die 1, and we know that die 1 is equal to the vector of the numbers 1 through 8, so it has 8 different elements in it. And I'm going to add that to the sequence 1 through 4, so 1, 2, 3, 4. So let's see what happens here. So notice we didn't get an error, but let's talk through what R actually did here. So the first element is going to be the first element of die 1 plus the first element of the sequence 1 through 4. In other words, 1 plus 1. And then we're going to get 2 plus 2, 3 plus 3, and 4 plus 4. But notice after this one, we've run out of elements in the sequence 1 through 4. So what R does is it just cycles back through the sequence and goes back to 1. So we have 5 plus 1, 6 plus 2, 7 plus 3, and 8 plus 4. So in this case, this worked because the length of die 1 is 8, and the length of the sequence 1 through 4 is 4. And 8 is divisible by 4. In other words, we can repeat that 1 through 4 so that it covers the length of the first one. Now, what if instead we had used the vector 1 through 3? Notice in this case, we're going to get an error message. And the reason for that is that 1 through 3 has length 3, and 8 is not divisible by 3. Or in other words, the longer object length, which is 8, is not a multiple of the shorter length, which is 3. Now, notice in this case, it's actually a warning, not an error. And the reason it's a warning is it does go ahead and give us an output, but it wants us to know, hey, this might not be what you intended, because the length of that shorter one, again, the longer one is not divisible by it. Right, so that's just a couple brief examples of how we can create objects, and we can do a couple things with them. Next, we're going to move on to functions, and we talked a little bit about functions before. So we know that a function will have a name, and it will be followed by an open and closed parentheses, and then anything inside of those parentheses is what we're going to perform that function on. So, for example, we might want to use the mean function, which is going to find the mean of some numbers. And so in this case, we might want to find the mean of the sequence 1 through 8. And so we could run this. And the average of the numbers 1 through 8 is 4.5. Instead of the sequence 1 through 8, we could have put the object die1 instead of the function. And notice that die1 is the sequence 1 through 8, so we should get the same answer. And we do. And then we can also put functions inside of functions. So here we have the round function, which is going to round the number. And inside of that one, we have the mean of die1. And that is going to round down to the whole number 4. Right? The next thing we're going to look at briefly is character strings. So far when we've been assigning objects values, we have assigned them numbers. We can also assign them what are called character strings. And so character strings, you can think of these as words or phrases, and there's different ways that we can assign them. So for example, and notice here I've got another word spelled wrong. For example, we could assign phrase 1 to be the phrase, there are 3 types of lies: lies, damn lies, and statistics. The key here is notice that I have this character string. On either side I have quotations. And this is what lets R know these aren't numbers, these are going to be characters. And so if I run this, notice that phrase 1 appears here in my environment, and we get that exact phrase. Now we could use single quotations, or we could use double quotations. So here's a second phrase. Facts are stubborn things, but statistics are pliable. And then we can actually also have quotes inside of our character string. And to do that, we need to use double quotations on the outside and a single on the inside. That's our quotes. So statistics is the main of all inaccurate studies. And notice I can call all 3 of these phrases. And we have those 3 phrases here. Now let's look at the length of these phrases. So again, here I'm going to use a function. This is the length function. And so notice the length of phrase 1 is just 1. So when we calculate or we find the length of a character string, it's how many character strings there are in the object. And so in this case, all of these letters and spaces together, those are a single string. So that's why we have length 1. If we look at the length of phrase 3, we'll see something very similar. You can also create empty strings. So to create an empty string, you just have 2 quotations with nothing in between. And so notice here we have an empty string. You can also do this by using the character function and just placing a 0 inside of that function. And so notice here it defines it a little bit differently, but both of these are empty. Now we can use the class function to see what kinds of strings these are. So the first one is a character, and so is the second one. We can also check the length of these strings. And you'll notice the difference here is that the first one has length 1 and the second one has length 0. So there are some background information about how these are treated a little bit differently, but both of these are empty. We can paste strings together. So for example, I could create an object called first name equal to Amanda. And notice here I'm using the equal sign instead of the left pointing arrow. It doesn't make a difference. Those can be used interchangeably in most situations. So first name is going to be the character string Amanda. Last name is going to be the character string Ellis. And I can use the paste function to paste those 2 together. So notice my name is now the character string Amanda Ellis. Now, one thing to notice here, when we use the paste function, if we look at the length of my name, notice that is just going to be 1 because it has combined those into a single character string. We can create strings and subtract or subset pieces from them. So here we could create a substring where our original string is twinkle twinkle little star, and we want to start at the 18th letter and stop at the 23rd. So before we actually run this, let's see if we can figure out what it is we expect to see. So we're going to start at the 18th letter, or we could say the 18th character. So starting with the T, we have 1, 2, 3, 4, 5, 6, 7, 8. We count the space, 9, 10, 11, 12, 13, 14, 15, 16. Count the space, 17. So the 18th letter is little. 19, 20, 21, 22, 23. The 23rd one is E. So we anticipate that this will take the string Twinkle Twinkle Little Star, start at the 18th letter, move to the 23rd, and pull that piece out. So we should just be left with the word little. So let's see if that happens. And in fact, we do just get the word little. We could also do substitution. So substitution, we could use the sub function. So we're going to substitute the word little for the word big in the phrase twinkle twinkle little star. And notice we get twinkle twinkle big star. We could also create a vector of character strings. Sorry, I realize I have lots of misspellings. I'm fixing as I go. So we could have a vector of character strings. So here I could define the object x. We're going to use that C function that we saw earlier to create vectors with numbers in them, except now I'm going to create a vector that has letters in it. So here the vector is going to have A, B, and C. You can see x is comprised of A, B, and C. And notice here that the length of x is 3 because x contains 3 separate character strings. And the quotations help us see where the separation of those character strings are. We can also have numbers that R sees as a character instead of numbers. So to see that, what we're going to do is we're going to assign y to be the object, which is a vector, which has A, B, C, and 1, 2, 3. And if we pull out the 4th element of y, which should be the 1, notice that that 1 has quotations around it. The reason for this is, and this is important, vectors can only have numbers or characters, not both. So if you have characters in your vector, R is automatically going to convert your numbers to be a character because you can't have both in there. All right, so the last thing, or one of the last things we're going to look at are data frames. So a data frame is going to have the following property, and these are essentially what you can think of as data sets in R. So each row is going to have the same number of columns, but each column can be a different data type. So numerical, categorical, factor, character, etc. So let's look at some example data frames. So I could create a vector of names. So we've got Susie, Bart, and Hope. I could also assign some ages to Susie, Bart, and Hope. So the ages are going to be 3, 2, and 6. I could have what's called a logical vector. We haven't seen these yet, but logical vectors take values true and false. And so you'll see those are kind of highlighted in yellow there. So this vector could represent whether or not the children have allergies. So we have true, false, true. And then I might want to take those 3 vectors and combine them into a data set. So I'm going to call this data set children. I'm going to use the data.frame function, and I'm going to combine name, age, and allergies. So notice we now have, instead of values, we now have a new section in our environment called data. And so children now appears here. Now, one of the things that we couldn't do with our values is we can see them here, but we can't really click on them and interact. Once we create a data frame, we can actually click on it and interact with it. One thing we can do is we can click the arrow and it will pull down each of the variables in that data set. The other thing we can do is we can double click on it and the data set will appear in a new window. We can close that out. We can pull individual variables from the data set using the $sign. So if we call children $age, we're going to get the ages of the children. We can also add new variables to our data set. So notice that when I defined age, I put quotations around those numbers. So R read those in as characters, but usually I really want age to be numeric. So one thing that I could do is I could use the $sign, type in a new object name. Here I'm going to call it age numeric. And I'm going to use the as.numeric function to convert the age variable. And so if I run this, notice that a new column is added to my data set, and we can double click on it to see that. And this is going to be the ages as numbers. And so one reason that this is important is if you wanted to, let's say, find the mean of the children's ages. If I tried using that original variable, and remember this one was coded as a category or as character strings, it's going to give me an error. It says I can't take the mean of characters. But, and you'll notice RStudio does this nice autofill that I'm going to use here. Let's say that instead I call that numeric one that I just made. Now I can find the mean of the ages of the children. So that's how you can make a data frame. There are also lots and lots of built-in data sets in R, and we'll be using those to illustrate a lot of different things in this course. So one way to see what the different data sets are is you can run this line of code. What this is this is going to tell you more about a package that is called data sets. And in this package, and we'll talk more about packages later on, you can see there are all of these different data sets. And like I said, we're going to use lots of these during our course. All right, so in particular, we are going to look at the state.x77 data set. So if I just run the name of the data set, it's going to populate here in the console. If I put a question mark in front of the name of the data set, what it's going to do here in the help window is actually pull up the information about that data set. And so we can see all the different variables that are in the data set. We can also get a little bit of description. And what you'll find is some descriptions are really long, some are really short. It just depends on whoever authored this particular data set. But this one is on US state facts and figures. One thing that I always recommend doing is that sometimes these built-in data sets aren't already a data frame. And so one thing that you can do is always, just to be safe, convert them over to a data frame. And that's what I've done here. So I'm going to create a new object called state.info. I'm going to take that state.x77 and convert it over to a data frame. And I do this using the as.dataframe function. And now we can explore that data frame. We can look at its class. We can see it as a data frame. The inRow function will tell us the number of rows. There are 50 rows, which isn't surprising if this is a data set about the states. We could see what columns or the number of columns that are included. So there are 8 different columns. And these columns are detailed here in that information about the data set. Using the names function, we can get the names of the columns. The head function is going to give us the first 6 rows of the data set, and the tail function is going to give us the last 6 rows of the data sets. We can call elements from that data frame. If we use the bracket notation, anything before the comma is going to represent the rows, and anything after is going to represent the columns. So if we call state info 1, 2, what this is saying is I want the element that's in the first row and the second column. And again, if we go over to our data set, you'll notice first row, second column is this value right here. We can also call these by column and row names. Now we do have to be careful and make sure that the data set has both named columns and rows. So if we look at the data set here, notice the rows do have names and the columns have names. So we could call the Kentucky row and the income column. And so we see this value is 3,712, which by itself isn't, terribly useful. We would need to come over here and actually see what income represents. And so this is the per capita income in 1974. Now these are individual elements. We may just want to call a column, and there are several ways if we just want to call a column. Now in the data set, the income column is the second data set, so we could use double brackets and call 2 to get the income column. We could also use a single bracket, place nothing before the comma, and a 2 after the comma, and notice we get the same values. We could use the double bracket and call income in quotations. We could use the $sign and call income, or we could use the single bracket with the comma and call income in quotations. So one way to think of this is that double brackets are always to call a column, whereas a single bracket will allow you to call row and column, and if you leave the row space blank, then you're just going to call that comma. You can do something very similar to reference a row. So to reference a row, we could use our single bracket, but let's say that I want to call the Kentucky row. Don't forget that R is case sensitive, comma, and leave nothing in the column space, and we'll see that we get the Kentucky row. All right, so the last thing here are base functions. You've seen several examples of functions in this video, and the last one, there are lots and lots of base functions, and the base functions are just the functions that come preloaded in R. And so I've got a link for here for you to visit to see a list of all the different base functions. There are tons and tons of them. So I do want to pause at this point and just to say, at no point do I want you to feel like the goal of this course is for you to memorize all of these functions or all of the syntax. No one does that. Really, the goal of this course is to get used to the different patterns. You'll memorize some of the functions, but just to understand the overall, the syntax and the organization of the code. If you can get to that point, then you don't need to memorize the functions because it'll become really easy for you to go to Google and say, hey, I want to do this. What do I need to do? You'll find your answer, you'll be able to read and understand that answer and go and write the code. I do that. There is hardly any time that I sit down to code something that I'm not going to use Google to help me. But again, I understand the syntax and the organization well enough that that's a pretty quick process for me, and I can go through and code really quickly. The other thing I really want to emphasize here at the end of this video is if you feel a little overwhelmed, don't worry. Everybody does the first time that you learn to code a new language. There's almost always a pretty steep learning curve, and you just kind of have to dive in and just really, take it a little bit by little, but, be willing to make mistakes and, to get errors and to try different things. And the more you expose yourself and the more that you try, the easier it's going to get. don't feel like, again, that after you watch this video you should be a master of any of the things that you saw here. It does take time, and the learning curve is steep, and that's what I'm here for, is to help you through that process. So don't feel overwhelmed. You're going to pick this up piece by piece. That's a very natural feeling, especially at this stage in the learning process, to feel a little bit uncomfortable, and that's just going to happen. So ask lots of questions. Don't be afraid to make mistakes. You can't break anything. And just know that I am here to help you.